Let's continue with the second example of internal rate of return with irregular cash flows. So we have a project with an initial investment of $200 at time zero, a cash inflow of $40 at the end of the next 13 years. And after year 13, dismantling the installations and cleaning up the field will cost the firm $5 in year 4, 1 minus 2% times $5 in year 15, 1 minus 2% squared times $5 in year 16, and so on into perpetuity. That is, the cleanup cost is $5 at time 14, and this cost will decrease at the rate of 2% annually into perpetuity. So this is a cleanup cost of $5 initially with a growth rate of minus 2%. So what is the range of discount rates with positive NPV for this project? So between 0 and whatever, or between two rates. So to select an answer that says between 0 and whatever, we need a project with a unique internal rate of return. And to select an answer with two interest rates different from 0, so we need to have a project with two internal rates of return. So initial investment of $200, cash inflow of $40 per year over 13 years. At the end, completely after 13 years, cleanup costs $5 at the growth rate of minus 2% forever. So 5 divided by R minus G. G is minus 2%. Let's first compute the NPV when the interest rate is equal to 0. So in this case, the net present value of the project is not minus infinite. So here, the net present value of the project is 70. Because 70 is larger than 0, this means that this project has a single internal rate of return, just like projects with regular cash flows. So the appropriate answer is one where we choose between, so we have an interval between 0 and a second interest rate. And we need to verify that the second interest rate mentioned is an internal rate of return. That is, a discount rate around which there's going to be a change in the sign of the NPV. So the net present value will go from positive to negative. The best option is that the NPV of this project is positive whenever the discount rate is between 0 and 17.1. Why? So if we compute the net present value at 17.1, we obtain 0.51. And when we compute net present value at 17.2, we obtain minus 0.29. So around 17.1, there is the net present value goes from positive to negative. So net present value enters negative territory at 17.2, which means that the internal rate of return of this project is somewhere around 17.1%. So this is what the graph of the NPV of this project looks like. Okay, so we begin with the sum of all cash flows equal to 70. It goes up initially and then falls, crosses 0 around 17.1, and then slowly converges towards minus 200. So the NPV of this project is positive for discount rates between 0 and approximately 17.1%.